Ya está.
Okay, so good evening, everyone. We are going to start the defense of the final degree project of the student Lucas Garcia Mateu, which is titled Mirror, a reflection tool for C++, directed by the professor Jesus Diaz. The thesis committee is made up of professors Ramon Santamaria as secretary, Lasse Loepfe as member, and myself, Aranzazu del Castillo, as president. Lucas, you have 20 minutes for your presentation, and then we will have time for questions. Okay, good luck.
Thank you very much. I'll start right away. Good afternoon, everyone. Welcome to the presentation for my final degree project, Mirror, a reflection system for C++. I am Lucas Garcia Mateu, and without further ado, let's get started. First, I'd like you to see an overview of what this presentation is going to look like. We'll go through a brief introduction of why I decided to pick this topic, as well as which were the objectives of the project at the beginning. Then we are gonna dive into the concept of reflection, defining it and seeing what practical applications we have, why are we interested in it. To afterwards discuss how we achieve this reflection system, and end with some conclusions of what went right, what went wrong during the project, what I have learned, and how the secondary objectives came together. So let's begin with introduction. At first, as this big question mark in this slide indicates, I didn't know what to pick as my final degree project. I had no idea, so I went to Jesus Diaz, who ended up being my tutor, and asked for a recommendation. The recommendation came in the form of a rather funny email after a story that we can talk about later in the question round. But basically, he introduced me to the concept of reflection superficially, and after investigating for a while, I decided to pick it up. The reason why I picked it up, it was not because I picked up the first thing that came to mind. I picked it up because it aligned with a set of expectations that I had for my final degree project. Expectations like it being programming related. The programming area of making video games is the one that I enjoy the most. And I also wanted to do something complex because I like to challenge myself. Also, I wanted to do in C++ because it's my favorite language and the one that I have more experience with. And we have lately been building high-scale, high-level applications such as games, engines, and all of this made me lose sight of the low level, the bare bones of it, where I think the great potential lies of the language, so I also wanted to go back to that. And finally, I wanted to make a tool or a library because, well, first thing, it's a brand new learning experience for me. I had never done it before. And additionally, I thought that, well, this industry has given me a lot of third-party tools to use and software that I have been using during my degree, and I think that it was time for me to give back something to the industry, give something to other developers to work with. So with this subject picked up, we define a set of objectives, right? The main one was, of course, and a big one, was building a C++ reflection system. This was the main objective of the work. But secondarily, we also had the tool. I wanted the tool to be accessible, and I wanted it to be game-oriented. So we will be talking about the main objectives for most of the presentation, but at the end, in the conclusions, we will discuss the other two topics. So what is reflection? What is this concept that we are going to be creating a system for? Let's define it. This is an object in C++, right? In object-oriented programming, we use objects because it is logical to group variables into like bigger variables, right? If we are going to have something representing a car, it is logical that a car is going to have... can you see my pointer? I hope so.
Yeah.
Okay, so a car is going to have a certain speed, a car is going to have a certain horsepower, it can be on and off, it will also have some actions that it can perform in the form of methods. So objects are the main tool that we use to organize data in a C++ program. And reflection is the data about how an object is organized, how an object is built. Questions like how many variables or properties are there in this object? There are 8 variables. How many methods do we have? We have 4 methods. So all of these are also, if we go specifically into a property, right, which is the name of the property or the variable, it's speed. Which type it is, it's an integer. All of these green answers are answers to be provided by a reflection system. This is because natively C++ doesn't have the capability of storing this information. Therefore, we need a system, a site, that it's going to be providing it to us in order for us to use it at runtime in the program and make computations or programmatic operations. So now we know what it is. Now we know which kind of data we are looking for, but why would we want it, right? Which is the practical application on all of this data? From a philosophical standpoint, I don't like putting a lot of text in slides, but this one it's a great quote in my opinion. From a philosophical standpoint, reflection means taking advantage of a task that is done when organizing the data of a program in objects, right? Because as coders, when we are building software, we have large amounts of data that we want to organize differently, right? And a lot of times we find ourselves asking, okay, should I build this object or should I build this other object? Should this go into a global variable? Should this go into an array? How do I set all of this data? And we spend a lot of time in there, right? And sometimes we forget that we spend that time and we do the work all over again. The brightest example of this is serialization. When we try to serialize, what we are doing is putting all of the data in this object into a file. So since the object is locked in a way, because C++ is so static of a language, the serialization code looks like this. It is something repetitive, it is something ugly, it's basically something that has no value whatsoever, right? Just someone has to go there and code all of this. The worst part it's not that it looks bad, it's that if we add a variable into this object, right here, shield defense for example, we have to go back and add a line of code into this code. And if we have multiple objects, we will have multiple functions. And this slide is intentionally this messy, right? Everything is on top of everything because it's how our code looks like when we have serialization. We have to have someone that is maintaining that code, that it's updating it as the project grows, and this slows down development and iteration time. And it's really bad for our project, basically. So in my opinion, reflection unlocks the full potential of objects when we are talking about C++, because we can serialize the whole object just with these lines of code. What, 5 lines of code? It is fantastic, it looks really good, but this is not the best. Like, again, code is not about looks, it's about performance, efficiency, but also flexibility. This code is really flexible in the sense that even if we add a variable, the code will still be the same. And if we have multiple objects, the code will still be the same piece of code. Because what is working, what is doing the work for us, instead of having to build different codes for each objects, we have the same code and different information for each object, which is provided to us by the reflection system, by Mirror. Alright, so this is one of the reasons why serialization is so useful. This is the tip of the iceberg, in a sense, right? But we have much more applications that we might be able to discuss at the questions round, because I have no time in this presentation. But as this slide is important for you to understand that it's only a system, it's only a set of data. What we do with it, what the user does with it, is up to the user, right? We are only building the system here. Alright, now we know what reflection is. Why would we be really interested in reflection? Why do we want it? How do we achieve it? How do we build it? Fine. This is the whole picture. This is how the mirror system works. The main parts of the mirror system are the mirror tool and the runtime library. Those are two really separate blocks, right? And the third element, of course, is the user's project. The way it works is that the mirror tool is going to be reading the files in the user's project, specifically the files where the objects are contained, the header files. Once we pass those objects, we will have the information stored in the mirror tool. And once the information is stored there, we can put it in the runtime library, which is automatically generated by the mirror tool, right? The runtime library is generated from scratch by the mirror tool. Well, not from scratch, from the user's project. And then our user can reuse all of these files that have been generated in order to access the reflection data at runtime. This is kind of a tongue twister, and I'd like to say it in this presentation. This project is about parsing C++ through a C++ application to generate some C++ files that are gonna reflect C++ objects. So since this is so complex and this is a tongue twister, let's remember this color coding to explain the different parts of the system. I'm gonna be using this color coding because we are gonna see a lot of code, and you are gonna know what these codes belong to depending on the color that we are using. So let's start by the runtime library. As you can see, it's purple. Let's start by the runtime library. This is how our user access the information of their objects while the program is running, right? We have this object, which is type info, and this is a generic container of metadata. This can contain the reflection data for any possible object, right? We have the variable name. If we remember the car object that we saw at the beginning, this variable is going to be initialized with the value of car. The property count will be 8, and the method count would be 4, like remembering the last slide. And basically this can store, depending on how it is initialized, it can store the data for any given object. And we also provide the user some utilities to navigate the instances of the objects that are being reflected, with to extract the properties and invoke the methods. Okay, so basically this is the whole library. This is what the user is really interested in, right? At a certain point he will need the reflection data for an object, and we have this mirror interface that has a singleton pattern, and we call upon this function with a certain object name, and the mirror class returns us an object that we can use to navigate the memory or access the reflection information or whatever our user is wanting to do. This is how we access the information from the program. The way I see it, the practical way I see it, I like to do this analogy, right? What is type info exactly? If we are coders and we are in the coding world, right, and we have the memory of an object, we can think of it as the sea. It's a really big, in the open sea, right? Have you ever been in the sea? It's open. It has a lot of space, and we can go to wherever we want. But the thing is that we feel lost if we don't have information of where things are. So type info becomes our map. Type info suddenly it's our map that tells us how all of this water, this memory is organized. So we can go there and extract the treasures, right? Extract the properties or invoke the methods that we are interested in, like coding pirates. But there's still one question left to answer, because if this container is something flexible, something that can contain the data of anything, it needs to be initialized somehow. Who does initialize it? Well, the mirror tool initializes it, because the mirror tool generates the runtime library. So the way it works basically is that if we have this class, that's our user's class, we are gonna make it pass through the application, right? And the application has some abstraction layers that we will talk about now, some processes, right? The tokenizer, the parser, and finally the code generator, which is gonna generate this code. That if you read this code for a moment, what it is doing, it is taking instances of the type info object within the mirror object and initializing them differently depending on what it's being read at the beginning, right? We have this input and this output. Basically it's the mirror tool. It's a program that has as an input a text file and as an output another text file. It's as simple as that. So this is the whole tool, and the beauty one of the beauties of making it in this way, this is one of the ways that we can approach a reflection system, it's that it simply has two files. The whole system is composed of two files, the mirror.x file and the config.json file. And the config.json file, it's basically I introduced it in the presentation because it's kind of a usability thing, right? So if we have this tool here, when we execute it, we have to inform it of, well, where the project files are located, right? We set a directory of where the project files are located, and then mirror iterates the directory looking for the objects. Then we specify where we want our generated objects to be, and afterwards we also set it as a set of reflection objects that we want to generate reflection for. We might not want to generate reflection for the whole project, so this option is also here. Now when the tool has been configured and it's executed, boop, we go to the tokenizer, and the tokenizer, what it's basically doing, I don't want to stop a lot in the tokenizer, because what we are working with in the very beginning of the program, is an array of characters, a really large array of characters, a text file, right? And this is really complicated to make operations with. So we basically turn this array of letters into words that already have some meaning, right, in the C++ language. From the words, we go to the sentences, and the sentences is what is really we are interested in. The sentences are the reflection data. So what the parser does, we now are in the parser, really smooth transition there. What the parser does is iterating this array of tokens and through an algorithm extracting the different reflection data. If you take a look at this object, it is really similar to type info. The reason being that it's storing exactly the same data that type info is, right? The name, the property count, etc. But this is within the scope of the mirror tool. That's why it's surrounded by green. It is not in the same context. It's C++ code, but it's in a different context. So let's take a look at an example of how the parser works. If we have my class, the parser will iterate the different tokens and we'll go, okay, so this is my the class keyword, right? So after the class keyword, what comes, the user bit that comes after the class keyword will be the name of the object. We keep iterating within the scope of an object, and if we find a type specifier, well, it is really likely to be a property. So we store the name of and the type into the properties array. And doing this iterative process, we end up with all the reflection data of our object. Now we have this data. What is left, it's unloading the data, right? And we unload it in the runtime library, which looks like this, right? And what the runtime library is doing is initialize one of the instances of metadata. I think I already said that, but yeah, the way this works is basically, if you think about the code generator, it's writing to a file from a program. This is something that students in their first degree does. This is something so simple. The only difference is that when we reach a certain point, when we are rating metadata name, okay, now with what comes, and the program will check the information that has previously been gathered. My class with the properties is kind of the same. Okay, we are gonna reflect this property, we are gonna write this property, metadata, push property, blah blah blah. Now we reach this point. What do we need? A, which is the name of the variable of my class. Offset, blah blah blah, A again. We put it here, and with this process we are basically writing all of the code that it's going to be now reused by our user's project. So that's it. That's how the whole system works, really. It's I'm not gonna say simple, it's kind of complicated, but think about this feedback loop, right? Where we read the data here, we parse it, we generate this, and then this is reused, right? This is the way, because the information that we need is in the same project that is going to be using the information. That's why it's called a reflection, right? Because it's like looking at itself. And well, we have added the config.json file here because it has already been explained. So, how much time do I have? Hello?
No.
All right.
3 minutes.
Fine, perfect. Let's run through the conclusions now. I'm not gonna stop a lot. This is just some conclusions on the final state of the project. So one of the secondary objectives was accessibility, and I think that through a really thorough documentation, some accessibility tests, as well as the simple design of the runtime library, I would give myself a pass in this objective. I think that it's something that has been achieved. I'm really happy about the tool being accessible, and it was important for me because I think that sometimes really complex tools tend to lose the focus on the user because they are too complex, and I didn't want to have that, and I didn't want that to happen with Mirror. Also, well, now let's talk about the game-oriented one. This is for games, it's really important. Efficiency is really important, and it hasn't been tested, so I don't know if it's efficient or not. And the high-level system would have been handy, and it's not implemented either. So definitely, this objective is it's the most underrepresented during the project. I don't think it gets a pass. I think it is a failed, but I don't think it's a failed objective either. Don't say the word failed, because I still think that Mirror can be used by games. The only thing it's that it has not been tested, right, or this objective has not been paid as much attention. So what we have in the end, what Mirror is really, what we have been talking about all the theory now, in the practical, Mirror is a prototype. It's really not something that you can just plug in into any C++ project and use it professionally, right? It's an idea, it's a demonstration of a system. Because it's a prototype because it's lacking some really important stuff. The main important stuff that it's lacking, it's huge improvement on the parser and the tokenizer. Code generation is a really powerful technique, but it requires us to basically compile C++, and that's a really complicated process. This is a list of the features that the system is missing, it's not going to support, and this is me doing reverse engineering, right? The list might be much longer. So yeah, this is a reality. However, it wouldn't have been possible to do it either, because it takes too much time to do a C++ compiler. However, this second error, it hurts me the most, is the most painful to me, because error logs basically attack accessibility, and the tool has no error logs whatsoever. When something goes wrong in Mirror, there is no error log, nothing tells you that it went wrong, and even if it's my biggest mistake, I think it's also my biggest learning about this project, that if I build a tool in the future, I think I will start, I will support errors from the beginning, right? Error logs are so important and haven't been achieved in this project. However, I am happy about it being a complete project, right? Even if it's a prototype, it's a complete prototype, it works under the context that it's supposed to work, and yeah, it's a milestone that has been achieved and could become much bigger in the future with a tiny bit more of, well, not tiny bit, but more work and more time, right? But it's a good milestone. Also, I'm happy about the accessibility. The fact that there are only 2 files that compose such a complex system, for me, it's a big win. It's something really good. I think it is handy to use. And I'm also finally happy about the documentation, meaning that the document that has been, the memory that has been produced for this project, right? I think that it is well structured, the writing is pretty good, the figures support the explanation well, so and it's pretty professional, so I think that the document is up to the standards of this university, this organization. That's it for the presentation. Thank you very much for listening, and I hope that now you see yourselves in the mirror.